All right, so we've talked about arithmetic sequences, we've talked about geometric sequences, we just talked about the recursive definition, which is a definition where you define any given term in a sequence based on the previous term. And today we're going to talk about explicit definitions. Now, the nice thing about explicit is it is used to define a specific term. That's a C at the end. Let's try that again. Specific term. I'm having issues writing today. Okay, term in the sequence. So it doesn't matter what term you're looking for. So if I want to know the 80th term, as long as I have an explicit definition, I can find the 80th term without needing to know the 79th term, which is really a nice thing. The kind of fun part is you guys have actually already seen the explicit arithmetic, explicit geometric definitions. So I'm going to zoom in just a little bit here. Explicit arithmetic is u sub n is equal to u sub 1 plus n minus 1 times d. That should look familiar because you've been using it for a little while. And the explicit geometric is u sub n is equal to u sub 1 times r to the n minus 1. Now, one of the things to notice about these two, remember I've said you don't have to memorize them, but you will need to know when to use them. If you remember, common ratio goes with the geometric, and common difference goes with arithmetic. That's a big hint in using these problems. Okay? So what I want to do next is actually write some explicit definitions. So problem number 1 here, example number 1, we have a sequence. We have the sequence 4, 7, 10, 13. So the first thing I want to do is figure out, am I talking arithmetic or am I talking geometric? And I'm going to look either for a common ratio or a common difference. Because I'm looking at this terms and realizing that each time I'm adding 3, this is 100% in arithmetic, and so I am just going to write out the arithmetic explicit definition. And part of this is you don't have to write it out repeatedly. I do because it helps you remember the formula by writing it repeatedly. All right? So now that you've written out the formula, what you need to do is plug in what you know. So we don't know which term we're looking for, but we do know what term we started with. That's 4. I don't know how many terms, right? That n value is unknown, but my common difference, I do know that, and that's that 3 that we did. Now, the step 3 here says to rejoice, so give yourself a little pat on the back. You've just written the explicit definition for that problem. So now if you want to know what the 20th term, you can use this equation. If you want to know the 2000th term, where n equals 2000, you can still use the equation. As long as you have the explicit definition, you can find any term in a sequence. All right, let's talk about number 2. So example number 2, we have an explicit definition I'm looking for. Sequence this time is -5, -10, -20, -40. So arithmetic or geometric, and the way you're going to know that is, are you looking at a common difference or a common ratio? And because it's going to take multiplying by 2 to get from term to term to term, I said multiplication, that's geometric. So u sub n is equal to u sub 1 times r to the n minus 1. That's the formula that we use, but now we want to fill in what information we know. So u sub n is equal to my first term times my common ratio is 2, and my exponent is going to be n minus 1, and that's all I know. Okay? Because we're not asking for a specific term in the sequence, we just write out the definition that way. So now that we know how to write these explicit definitions, we're going to put a little practice in place. We've got 3, 4, 5, and 6 asking for specific terms in a sequence. So let's do a little practice here. All right, problem number 3, 43rd term. So I know that n is equal to 43. I know u sub 1 is equal to 5. And for this case, if I'm going 5, 10, 15, 20, I have a common difference of 5. I'm adding 5 every time I'm moving from term to term. As soon as I say common difference, you should be thinking of that arithmetic equation. So u sub n is equal to u sub 1 plus n minus 1 times d. And I'm looking for the 43rd term. So my first term was 5, plus my n value is 43 minus 1, and then my d value is 5. So I'm going to grab my handy-dandy calculator. I am going to put the entire right side of the problem there in my calculator at once because, well, I'm lazy, and I'm going to make my calculator do this work. All right, so if your calculator tells you the correct answer, which hopefully it does, you should get an answer of 215. All right, so that's what happens if you have an arithmetic. Let's check out problem number 4 here and see what happens with this one. All right, so 14th term. So n is equal to 14. I know u sub 1 is equal to 1/2. Now I've got to figure out common difference, common ratio. Well, to get from 1/2 to 2, I need to multiply times 4. 2 to 8 times by 4, so this is a common ratio of 4. Okay, so common ratio tells me I'm dealing with geometric. So u sub 1 times r to the n minus 1. So I'm looking for u sub 14. First term's 1/2 times 4. I'm going to zoom in just a little bit. And I've got 14 minus 1. Now, I don't know about you guys, but I don't believe that I can handle doing 4 to the 13th, right? 14 minus 1 is 13. So 4 to the 13th is not going to happen in my head. I'm sorry. If you can do that in your head, I am impressed beyond all belief. So u sub 14 is equal to, let me make sure I get all these digits right. 3, 3, 5, 5, 4, 4, 3, 2. Let's put in all the commas I need here. Quite a significantly large number, okay? But that's part of the geometric sequence is if you have a multiplier, right, a common ratio that even if it's only 4, right, it's going to grow very, very quickly. Geometric sequences, when they have a ratio greater than 1, are exponential growth. All right, so I don't know if you've ever heard of exponential growth before, but basically it is a form of a geometric sequence. Okay, so hopefully that helps with number 4. I'm going to take another minute or two and finish up problem number 5 and 6. All right, I am looking for the 99th term, so n equals 99. I know my first term, 24, and to get from term to term to term here, I am adding 2 each time, so my d value is 2. So let's see, I want u sub 99 to equal my first term plus n minus 1 times d. So let's go ahead and whip that into a calculator. Let's see, negative 24 plus 99 minus 1 times 2. My 99th term, so u sub 99 is equal to 172. Okay. And last but not least, example number 6 here. Find the 20th term, so n is equal to 20, u sub 1 is equal to 2. To get from 2 to 6, and then 6 to 18, and then 18 to 54, you are multiplying times 3 each time. So that means my common ratio is 3. So let's see, u sub 20 is equal to my first term times my common ratio raised to the n minus 1 power. So as I said, this is the common ratio in this case is greater than 1. So this is going to be exponential growth of some kind, which means that that 2 times 3 to the 19th is going to be a significantly large number. I've had students in the past, when they put this in their calculator, they immediately think that they've gotten the wrong answer because there are quite a few digits here. All right. Yeah, that's the 20th term of that sequence. All right. So what is that? 2,324,522,934. Because that just rolls off the rolls off my tongue really easily there to say it. If I had to keep thinking about how many spaces it was out. All right, so guys and ladies, that concludes this video in terms of the explicit definitions. If you have any questions or concerns, absolutely let me know.